Greetings, YouTube. This is Beautiful Mind, aka Professor Pfeiffer, or Professor C. Let me see. So feel free to either type in the chat or unmute yourself if you have questions. Otherwise, we're just going to kind of jump into the material. No major announcements. We're about the middle of week 3. Okay, so we're going to keep making our way through section 1.3. If we finish the assigned homework probably today, more than likely, I'm going to create some more assignments that we can add and just continue practicing our factoring. And then we can also be on the lookout for exam 1 to open up next Wednesday. So not tomorrow, but a week from tomorrow. Okay. So again, if you have questions, feel free to type it in the chat or unmute yourself. Else, I'm just going to kind of jump into the material. Okay. I'm going to close this out. Okay. I would like to have a little bit of the audio so I can hear it. Turn it up just a little bit more. Okay. We'll try that. Okay, so let's hop over to Pearson. There it is. And I think we can use this technique. I think it'll work. Okay, so we're continuing where we left off from last time, section 1.3 on functions. And we're asked to answer the following questions about functions, okay? So I'm gonna need to take some notes on my end. So let me kind of get set up. Let's see. So I like to do paper, lines, no, grid paper. So again, this comes from week 3. Week 3, section 1.3 functions. Okay. This is question number 16 from this assignment. Okay. And this comes from section 1.3, question 45. So we're given this f of x, this function, and I'm just taking notes. I know you can't see it right now. I'm just taking notes before we hop over to the tablet. F of x is 3x squared minus x minus 2. Also, we can use this time to go through homework questions that you may have, or just any questions in general. We don't have to go through this the way we're doing it. I'm just doing it because students generally don't ask questions. We do have tutors. If you would like the tutor information, let me know. I can forward the email that I got. But yeah, and let me take all these notes. So then A is -1, 2 on the graph. Okay. B, if x equals 2, then what does f of x equal? Okay. C, if f of x equals 2, if f of x equals -2, then what does x equal? Okay. And then D is, I'm going to say domain, question mark. E, x-intercepts. And F, y-intercepts. Okay. So this is pretty thorough. That's why I remember when I saw it last class, I was like, let me save that for next one because it's a little bit intense. So it's not intense, it's just a good amount of information. Okay, I'm going to trust that works because it's been working pretty consistently. Okay. So the first question is -1, 2 a point on the graph, right? So for this to be the case, when x is -1, y should be -2, right? So for part A, f of x, who we got? Let's do it. Okay, got him, coach. Come on in, brother. Okay, f of x equals 3x squared minus x minus 2. We could probably factor this. We'll factor it later because I think it pops up a little bit later. So the first question is -1, 2 on the graph, right? So I'm going to say let x equal -1, right? So if we let x be -1. So then if we do f of -1, that's going to be 3 times -1 squared minus -1 minus 2. Okay. -1 times -1 is +1, so that's going to be 3. Double negative is +1 minus 2. So 4 minus 2 is 2, and 2 is indeed the desired output that we wanted. So is that on the graph? We would say yes for that one. Okay. And again, just to kind of reiterate, I know earlier in the first couple of lectures I mentioned something about Alex. We're not going to be using Alex. That program I think is kind of intended for like students of the fall. It might expire on students in this term, so we're not going to use that as a lab portion. The lab portion, basically, I'm just going to kind of be adding additional or supplemental material into our homework section. And the main thing is just, with my course, the main thing is just basically get your attendance credit. Like just check in each class, just pop in, right when class starts. Like try to be waiting like that 10 minutes leading up to class, just try to be there. Preferably within the first 15 minutes, because it might get to a point where after 15 minutes, I'll let people in, but I won't give them attendance credit. But with attendance credit, and then the other thing is just get all those assignments completed with whatever grade you want on Blackboard/Pearson, and you're good to go. And then just P's and Q's, smile, keep it moving. It's nothing, And if you need support, you have support. Like honestly, you can link up with the tutors and just make your way through it. Get it done, do the best you can, because one day you're going to be accountable for this kind of stuff. Like people are going to ask you questions and you might have to do it in person. But just get it done. Like I feel like this removes a lot of anxiety. There's a way around the anxiety that comes naturally with this material, right? And depending on what you want out of the experience, I mean, you can, if you want to learn all of it, you can learn every little nuance. Because everything has an explanation. Let's keep going. Okay, let me get a copy of this guy. So again, the function is this guy, 3x squared minus x minus 2. And then question B asks, if x equals 2, then what's f of x, okay? So we're asked to evaluate f of 2. So then we're just going to do, so again, whenever we're doing these substitutions, my recommendation is to first replace each x with a blank set of parentheses. Hopefully that music isn't too loud. Because I know I have it dialed up a little bit higher than what I hear. The whole audio thing, it took my whole weekend, like all of Saturday, for me to figure that out. I was like, man, to how to feed the line so that I can hear it. So not only record the audio, but monitor the audio. That took like, ugh. And I just got lucky. I just kept playing with the settings, and then finally it started working. I was like, oh, okay, I see it now. So anyway, but yeah, whenever we do our substitution, my recommendation is to replace each x with a blank set of parentheses. Okay, so then here we would say 3 times x squared minus x minus 2, and then we plug in whatever number is in question. So let me do it like this. So we'll do one of my favorite colors. We'll use blue. Right, so we're going to plug that blue thing into each blank parentheses. Okay, so then we can just evaluate. So 2 times 2 is 4. Let me mention this since we have time and I don't have to rush so much. So if we look at this term here, we got 3 times 2 squared, right? So I usually say something about order of operations. You may have heard it as like PEMDAS or please excuse my dear Aunt Sally. Let me just mention this really quickly. So this is just like a side note. I'm going to say order of operations. This tells, because like the order in which we execute these this arithmetic, the order in which we do it, it affects the outcome, right? So there's a certain order in which we do these things. There's an order of priority, right? So this is where PEMDAS, and I learned it as PEMDAS LR. So please excuse my dear Aunt Sally's last request, right? So then the P stands for parentheses. So that means if we have any grouping symbols, we want to address those first. We tackle the grouping symbols from the innermost nested set of parentheses. We're working our way out, right? So we address any parentheses first, and then after parentheses, we address any exponents, right? So like if we look at our example, we introduce these parentheses, but within the parentheses, there's nothing to simplify. So then we will go to the second, which is exponent. So that's why I was squaring this guy first before multiplying by 3, right? Because of this order of operations here, okay? So once we've kind of done what we can do with the parentheses, we've done the exponents, next thing is, like, I know we haven't really been going back and forth, but if we were in each other's presence, I would ask you, well, do you always multiply before you divide? Or like, how does that work? What's next? Do we multiply next? Do we divide next? What's next, right? I would pause for a moment. Sometimes students say, yeah, we multiply next. And I was like, well, sometimes we actually do divide first, right? So with multiplication and division, what we have to do, we actually should group those together, right? And so whenever we're on a line and we have to decide between multiplication and division, we just do that left to right. That's what the LR comes in, left to right, right? So the M stands for multiply and D stands for division or divide, right? So sometimes we do divide before we multiply. I think there was a meme going around the internet last year sometime, like the math equation that's destroying the internet. I can't think of it offhand, but it was basically an argument over order of operation, and you just kind of have to do it based on, because apparently in some parts of the world they do a different order, and you know it would create a different result. But the way we're doing it is the way I'm seeing it. So I mean, and don't take my word for it. You could always like research it and cross-reference and double check, because I'm a spiritual being having a human experience like everybody else, right? So that means I'm allowed to make mistakes, as are you. When you're in human form, you're allowed to make mistakes. You know. Anyway, so progressing forward, again, similar to multiplication and division, we also group addition and subtraction. So, you know, sometimes we might subtract, we just do that left to right. So whenever we have to decide between addition and subtraction, we just do it left to right. And then again, the L stands for left, and the R stands for the right. So we just do these things from the left to the right whenever we have to decide between those grouped. Okay, those grouped operations. Okay, so I usually like to mention that because this is kind of like an introduction to like college math. I mean, you know, advanced math, but the better your foundation, the higher you can go. If you have like a jarring experience and you're intimidated, people often run from math their entire life, but every time they turn around, they go to apply for a job. What's that first thing they give them at the interview process? Here, take this math exam. Or, you know, every time they turn around, it's there. You know, we can run as far as we want, but we can only run but so far from ourselves, you know? So long story short, until you face the energy with grace, it'll always be in your face. Okay, that's enough of that, because I can keep going with those, by the way. So anyway, so that's order of operations. I did want to mention that just to kind of plant it in minds and just bring it to your awareness. So if we go back to hours and pick up where we left off, so if we're looking at this term, right, again, within our parentheses, there's nothing to simplify. So we would go to exponents. So that's why we did 2 squared first, and it gave us 4. And then 4 times 3. After exponents, we would multiply or divide, right? So let's pick it back up. So then that's going to be 4 times 3 is 12 minus 2 minus 2, right? This is all addition and subtraction. So 12 minus 2 is 10, minus another 2 is going to be 8. So when x is 2, when the input is 2, the output is 8. Okay, hopefully that made sense and it wasn't too wordy. Copy. But I guess a part of me feels like, well, if these are recorded sessions, you could always pause it, rewind it. You can, if you're watching this, like, aside from right now, you can play it in like double time. I've had students like watch videos in double time, and you can still hear enough of whatever's being conveyed, and it takes you half the amount of time to get through the material. I thought it was a fantastic idea. I don't really do it, but I thought it was a good idea. If f of x equals -2, then what's x? Okay, so for C, we said, so we're gonna say f of x equal to, I think it was -2. -2, right? So then that means, so then I'm going to say x equals question mark. So we would take f of x, which is this 3x squared minus x minus 2. We want to set that equal to -2, and we want to solve for x, right? So what I would do, I would set it to 0. If we add 2 to both sides, let me write that out. And when I say both sides, I mean the left and right side of the equal sign. So just like in life, we want to be balanced. What we do to one side, we do to the other, right? So then a number plus its opposite adds to 0. Again, both of these add to 0. And what's left, we have this 3x squared minus x equals 0. Okay, here, both terms have an x, so we can factor out x from both terms. And we're going to be left with 3x minus 1, right? So then at this point, we can use the zero factor property. I'm going to write it here. Let me see. Zero factor property. I don't know about you guys. It's like the weather today was like crazy. I don't know if it's still like really cold out there here. Like we're in Atlanta. I went out and I had to get a new tire. So that was pain and pleasure. It's a pain because you're spending money that you didn't intend to spend, but I like the way my dad articulated. He was like, be glad that you can pay for the repair. It would be worse if you couldn't pay for the repair. I was like, damn it. He's right. So that just helps me to just do what I got to do and keep it moving and make it play. But yeah, the weather is like, it's like super clear now. It was out overcast earlier, but anyway. So we have two, that's too small. I can't, and I'm out of space. I'm just gonna let that be for now. Let's do like this. Let's undo, undo, undo. Come on, keep going. Yeah. I feel like I can make it a little bit more clear here. All right, that'll do. Okay. So the zero factor property says that when we have two or more things that multiply to give us zero, basically you set each thing to zero and solve. Because if this first thing is zero, zero times anything, everything collapses to zero. If this second thing is zero, zero times anything is gonna be zero. So we set each thing to zero and solve. X equals 0 or 3x minus 1 equals 0. The first one's already solved for us. We add 1 on both sides. Okay. So then we get 3x equals 1, x equals a third. Okay. So then, let me think. When y was -2, we got two values. So we got 1/3, comma, -2, and we got 0, comma, -2. And then for the previous one, let me kind of, I think they wanted the ordered pair. That was the ordered pair 2, comma 8. Looks like we kind of have who we're going to have today. I'm going to have to track down some students. I noticed that we've been having like a lot of people missing. That's going to affect their money. Like I don't know how to make it more, I don't want to use the word easy because I'm not thinking it's not really easy, but you know, more within your grasp than the way that I'm doing it. Anyway, that doesn't concern you guys. Paste. Okay, let's see. So that was C. Oh, then the domain. Okay, let me get a copy of the original again. So then ABCD. 3x squared minus x minus 2. 3x squared minus x minus 2. That's f of x. And we're asked to find the domain. Okay. So in general, like this is called a polynomial, right? This is a quadratic polynomial. A polynomial is a finite sum of monomials. What's a monomial? A monomial is a term that looks like this, where you have some real coefficient times a variable raised to some non-negative integer exponent, right? So a monomial is going to have some real coefficient, some real number as a coefficient, times a variable raised to a non-negative, non-negative integer exponent, right? So then a polynomial is a finite sum of monomials. These are three monomials. So this is called a trinomial, right? So in general, for a polynomial, finite sum of monomials, the domain is all reals. So for something like this, the domain would be all reals. All reals. Okay. Or, you know, negative infinity to infinity. Let me see, can I just paste? Yeah, that's what I want. Okay, let's look at E. So the X for the domain, and then E, x-intercepts and F are the y-intercepts. I'm gonna say x-intercepts. Okay, so to find the x-intercepts, what we do is set y equal to 0. All right, let me check the chat. Chat looks okay. Cool beans. All right, we set y equal to 0. Okay, so we have this function here, f of x equals 3x squared minus x minus 2, y equal to 0, okay? So if we set y equal to 0, we're going to have 3x squared minus x minus 2 equals 0. And so we have a trinomial. We could use a quadratic formula. We could use completing the square. I'm going to see, can I factor this? We do expect you to already know factoring coming into college algebra. If you're not comfortable with college algebra, like that's why I keep doing those supplemental materials on like the Thursday and Friday. I know we kind of finish these lectures or the homework by like Tuesday oftentimes. So, but I know a lot of students generally have a hard time with factoring. So that's why I was like, okay, well, let me introduce or provide some supplemental factoring practice. So that's what I've been using my Thursdays and Fridays for. Okay, so let's see. So we want to factor this. We're trying to factor. We want to find two numbers that multiply to give us, it's actually -6 here, right? A times C. Two numbers that multiply to give us -6 and add to give us -1. I think it's -3 and 2, right? So what we're going to do, we're going to rewrite this middle term using that -3 and 2 that that's too bright. That -3 and 2 that we just found, all right? So then we'll have 3x squared minus 3x plus 2x minus 2, right? Notice -3 times 2 is -6. -3 plus 2 is -1. So these two numbers are good. So we broke the trinomial up into a polynomial with 4 or more terms. So now we can use factor by grouping. When we're trying to factor and we have 4 or more terms, we use the technique of factor by grouping. So if we group the first two terms together, what do they have in common? They both have the 3x. What's left? If we remove 3x, we're left with x minus 1, right? The hint is we're kind of looking for another of this blue thing in the second half. So a lot of times what I'll do, I'll just go ahead and write it, x minus 1, because that's what we're looking for. And see, okay, can I find a factor such that that's the result? So if I look at the two on the right, what do they have in common? Well, we can factor out a +2 from both of those, so +2. Notice if we factor out +2, it leaves us with the desired result of x minus 1, right? And this is still equal to 0. At this point, so we still have two main terms, and each term has a common element, right? What do they have in common? They both have that blue thing, right? We call that the common binomial factor. So we can actually factor the blue thing out of both, right? So then we'll have x minus 1. Now if we remove the blue thing from the first one, that leaves us with 3x. If we remove the blue thing from the second one, that leaves us with +2, right? One of the things, and this is a little bit of philosophy and like personal observation, but I feel like part of the thing, aside from having a jarring introduction to mathematics, another thing about math that people just run away from is the fact that you have to slow down. Like, because this society is all about, it's like a microwave generation. You know, we have everything on the internet. We have powerful computers in our pocket. We have like these smart assistants like Siri and Alexa and Google and all this stuff. So we don't really have to think, right? We don't know how to do things on our own. Like if all this stuff shut down, what would you be able to do? Would you know how to communicate? Would you know how to navigate, right? And so mathematics kind of empowers you, but people are lazy. It's only natural. There's nothing wrong with it. It's natural. Energy follows the path of least resistance, right? So, I mean, I'm guilty of it. I do the best that I can, but math, it forces you to slow down and it forces you to actually work to empower yourself, which is, you know, unnatural. You know what I mean? So that a lot of people don't even want to take the time to like empower themselves in that way. So it takes a special individual to do this. I never really agree with making everybody do it. I never thought it was for everybody. So I really just make this stuff to try to reach out to anybody that's interested, and I just try to do whatever I'm supposed to do and keep it moving. But if it were up to me, I'd be like, okay, anybody that wants to know, I'm willing to share. But if you're not interested, don't waste your time. Like that's, if it were up to me, that's what I would do. But it's not up to me at this stage, in this form, in this position. So I was like, well, I'm gonna just do what I can until things change, or until I make a change. Cause like nothing's really gonna change until I take initiative, but that's where we are right now. Okay, enough of that. just a little bit of, backstory. So at this point, it should be clear what to do, right? We can use the zero factor property. We have two or more things that multiply to give us zero. So then we just set each thing to zero and solve. So we have this x minus 1 equals 0, or 3x plus 2 equals 0. I kind of keep wanting to go on about my philosophy, but I don't think it's the proper time and place. Like, we're here to talk about math. I mean, even though it is mathematics and it's math in orientation and it's math related, but let's kind of focus on this. So then if we solve the first one, we add 1 to both sides. I guess I can show it, plus 1 and plus 1. Then we get x equals 1, right? And then on the second one, we subtract 2 on both sides. We have this 3x equals negative 2, and then divide both sides by 3. And so we're constantly using the inverse operation, right? Like, for instance, in this first one, if we're trying to solve for x, we want to move the 1 away from the x, right? So in order to move the 1 away, that's a tongue twister, what's the inverse operation of subtraction? Addition, right? So that's why on the left, they add up to 0, and then we moved it to the other side. Same thing on the right-hand side, right? So if we want to move this 2 to the other side, what's the inverse operation of addition? That's why we subtracted 2 on both sides. Notice here we have 3 times x. What's the inverse operation? Oh, well, the opposite of multiplication is division. So that's why we divided both sides by 3, right? So we're constantly using this inverse operation to get the to isolate the variable. So we get a result of a negative 2 by 3. Okay, let's go back and answer the question. X-intercepts. So we got 1, 0, and a negative 2/3, right? So the x-intercepts we got 1, 0, we got a negative 2/3, 0, right? So we should check this. We can check this before going forward. We can check and see, okay, does this work, right? We can check a lot of our stuff. Let me see. We'll go back and check. I'll do that. Let me go ahead and do this last question, or this last part, which is the y-intercept, and then we'll go back and check our work. So then f, let's be consistent. I don't even know what I just did there. F, we're going to say y-intercept, question mark. To find the y-intercept, we set x equal to 0. That comes out of, if we look along the y-axis, we ask ourselves, well, what's the value of x? No matter where we are on the y-axis. No matter where we are on the y-axis, the value of x is 0. So that's why we do it this way, right? Every maneuver has an intent behind it. Anyway, so to me, the y-intercept is often easier to find than the x-intercept if it exists. 3x squared minus x minus 2 squared. Okay, that's f of x. Okay. So if we set x equal to 0, that's going to give us f of 0 here. Let's do our blank parentheses. Replace each x with a blank set of parentheses. And then we're plugging in x equals 0. Right? That helps us to keep track of signs if there are any, like plus and minus or whatever. So then what happens, this term goes to 0, this term goes to 0, and the only thing that's left is negative 2. Right? So then the y-intercept is going to be 0, negative 2. Okay, so before we submit this stuff on Pearson, what helps is if you know how to check this stuff, right? Whenever possible. We don't always have that luxury, but whenever we do, we drastically boost the odds of success in our favor, right? So what I'm going to do, first I'm going to break out my trusty dusty. Well, give me just a moment. I'm going to hop back over. Let's do like that. For the people at home, let me go ahead and do this as well. I'm going to go ahead and close out my attendance because it's cancel. Oh no. Oh no. Oh no. It looks like we lost where we were working. Oh no. I should have finished the question before I did this. Let me go ahead and close up my attendance first. We're gonna have to see what's going on with people. Okay. And then let's hop back over here. Looks like we lost our work. Okay, so now I gotta try to recover somehow. I'm gonna just reload it. Hopefully it doesn't change it. It's not looking good. Okay, let's see. Ooh, I think we got lucky. Ooh, okay, we're gonna see as we go. I'm gonna put it back. Let me check. Let me check here. That looks good. Those are good. Okay. Actually, let's check our work before we submit it. So I was trying to show you how to check. Come on, cut that out. So let's go like this, like this. I'm working on my trusty, dusty, rusty. Come on, here you are. Calculator. Reload and refresh. Okay, that looks good. Okay, let's show the calculator. Come on. So, oh, and then let's hop over here so you guys can see it. Okay. So what I'm going to do, this is a TI-83 Plus emulator. So I'm going to go to my y equals in the upper left hand corner, and I'm going to type the function in. 3x, the original function, 3x squared minus x minus 2. Okay, then I'm just go through and check our results and see if they make sense. Oh, it's doing that thing. It's so irritating. Okay, so I'm going to quit. I'm going to go, so to the left of the clear button is this button that says variables, VARS. I'm going to click there. Let's move this a little bit out of the way. So right here, I'm going to click variables. Variables, I'm going to go to the right to Y variables, click on number 1 function and number 1 Y1, right? So then for A, it says let X be -1. So when X is -1, we got a result of 2 and we confirmed it, right? If we go to B, okay, when X is 2, right? So I'm going to recall that, and I want to see what happens when X is 2. The output should be 8. Okay, so we got the same thing there. For C, when X is a third, Y should be -2. So let's see, 1/3. Y should be -2, and when X is 0, Y should be -2. Okay, so those check out. Domain, you can use, like look at the graph. That one, I would just say, again, because it's a polynomial, the domain in general for polynomials is all real. Okay, every X is accounted for. The domain is going to be a set of input values. So the X-intercept, we got 2 values. X-intercept, we got when X was 1, wait a minute, yeah, that gave output of 0. And when X is a -2/3. I think we did that one already, but I'm gonna do it again. So those both work. And then the Y-intercept, when X was 0, we got a Y-intercept of -2. You can actually see it at the top of the screen. Okay. Okay, so we checked, we confirmed the results that we got. That's about the best we can do before we submit it. Okay, so let's hop back here and let's submit what we got. I'm gonna have to reboot this. So it's doing that lag thing. Hopefully, oh no, I realized, oh, hopefully it doesn't erase our work, because it's infamous for that. When it starts lagging, oh, I'm having so many. Let me go to the end. It looks good. Okay, I think we're okay. Okay. So if we go to A, we got, let me see, is this on the graph? We said yes. So we're gonna put yes and hit enter, okay. When X was 2, type in integer or simplified fraction, then the Y value was 8. Okay. What's the point? So the point's going to be 2,8, parentheses 2,8. Let me see the time. Okay, we go from, yeah, until 6:30. Okay. When Y is -2, the X value was, so that was what, C? We got 2 results. Type an integer, use commas to separate answers as needed. So when Y was -2, we got 1/3 and we got 0. We got 0, 1/3. Okay. It's the point or points. So we got 0, -2, and we got 1/3, comma, -2, okay? Domain, all rules, interval notation, parentheses, negative infinity up to infinity, okay? X-intercepts, we got 1, 0, 1, 0, and -2/3. So like, if you're confident, or like if I would try to get ahead, like honestly, you can get pretty far ahead of my class. It'll help you with your other classes. Let me think about this. What did I do wrong? We confirmed the numbers. X-intercepts. Let me see, did I type something wrong? E, all right? Set y to 0. We checked both of these. Oh, integer. Oh, okay. I put it in. Let me copy this so I don't have to type it again. Copy. They just want that, and they want this, and then they want the. Oh, they didn't even want the order pair. Okay. So then F, we got -2. Okay. I was saying something else. I totally got distracted when it got wrong, but that's okay. All right, let's go to the next one. Refer to this graph shown to the right. Find the domain of the function. So the domain is the very left to the very right. All right. So how far left does it go? The far left is -8. There are no arrows going to the left to imply continue the pattern. So the very left is -8. How far right does the graph go? Off to positive infinity. So here, the domain, the far left is -8. The far right is infinity. Infinity always gets a parentheses as a grouping symbol. And the grouping symbol here is important. You got to ask yourself, is it a parentheses or is it a square bracket? Parentheses means we get really, really close to that number, but we don't touch it. Square brackets mean we get really, really close to that number and we do touch it, or we do include it, right? So this is an example of something that would be square brackets. Okay. Use the graph to find the indicated value. So when x is 3, right here, when x is 3, y is -3. Okay, that was pretty straightforward. Refer to the graph and the figure. The axes are marked off in 1 unit intervals. What is x when y is 7? So y equals to 7 is here. So all these, okay, so the far left is -infinity up until 4, and then from 4 to infinity. So if x is any of these numbers, the output, the y value is 7. So I will go with E. Okay. The perimeter of a square tile is a function of the length x of a side of the square. Write a function rule for the perimeter. Okay, let me, I kind of want to, I'm just going to, it says the perimeter of a square tile is a function of the length x. So we have a square where the side is x. Write a function rule for the perimeter of a square tile. Oh, so if we have a square and one side is x, what's the property of squares? All the sides are the same, right? So if one side is x, that means all the sides are x, and so x added up 4 times is just 4x. Okay. So then when x is 10, the output is 40. Okay. Perimeter. So the perimeter of a square with sides of length 10 is equal to this value. Yep. The length of the side square whose perimeter is 10. No, the perimeter is not 10. In this case, the perimeter is 40 and the side is 10. Okay, so I'm going to go with A. We are like finishing things rather quickly. I don't think we finished all the factoring, so I might go back to the old assignment today, and then I'll make some stuff for like Thursday and Friday. Students stuff envelopes for extra money. Their initial cost to obtain the information for the job was $400. Each envelope costs 2 cents and they get paid 6 cents for each envelope stuffed. Let X represent the number of envelopes stuffed. Express the cost as a function of X, express the revenue as a function of X, and then determine analytically the value of X, which the revenue equals the cost. Okay. The cost. So the initial cost to obtain the information was $400, and then each envelope costs 2 cents. All right. So you got to take that $400 plus 2 cents for every envelope. So we would say 0.02x plus 400. They paid the $400 plus 2 cents for each envelope. The revenue, so for each envelope they stuff, they get paid 6 cents. So that's going to be 0.06 times X. So the revenue equals the cost. So when X equals, we should probably write that out. Let me see. Let's write it out. This is question 21. This comes from section 1363. This is part C. So we want to set the revenue equal to the cost function. The revenue function we got was 0.06x. We're going to set that equal to 0.02x plus 400. Okay. Let's hop over here. Okay, so now you could keep the decimals if you want. Like you could subtract 0.02, you get a result and work it that way. I just want to introduce or show this technique for clearing out decimals. We have a technique where we can actually clear out the decimals and proceed. So because the highest number of decimal places we have are 2 decimal places, we're going to multiply by the appropriate power of 10, which in this case we're going to multiply both sides by 100, right? So if we multiply this by 100 and this side by 100, on the right hand side we're going to need to distribute that 100, right? So then if we, and you don't have to do this, I'm just showing you how to clear out decimals if you want it. So then on the left we get 6x, on the right we get 2x plus 400 with 2 zeros, right? 40,000. Right? So now if we solve this equation, we subtract 2x from both sides, we get 4x, 40,000. Then divide both sides by 4, x equals 10,000. Right? Okay, so let's go back and answer the question being asked. So the revenue equals the cost when we produce and stuff 10,000 envelopes, 10,000. Right, so then what that means is that if that's when the revenue equals the cost, then we don't turn a profit until we produce more than 10,000. When we stuff more than 10,000 envelopes, right? That's when we start to turn a profit. But anything below 10,000 is coming out of, you're in the red there, okay? Let me kind of look at the previous homework assignment. Let's spend some time there for a moment, the factoring. I can get it to work. Okay. Here, let me turn up the music while I'm working. Give me just a moment. So let me see. It would be nice if we would just show the score. So we just finished 1.3. We could go ahead and do the quiz. Okay. Let me So we already have a quiz available for this material, so we're gonna go ahead and like see how we can do. See if we can get 100 on this quiz. All right. Okay, determine whether the following equation, because so the quizzes, you know, they're really short, right? But they're similar to like the exams, right? So where we still get unlimited attempts, but we don't get the support, right? So it's either we don't know our score until the end. Determine whether the following equation defines y as a function of x. I'm just going to say yes, right? Because if we solve for y, it's going to be just a diagonal line, right? So it's going to pass the vertical line test. So I'm going to go yes there. Go on to the next one. Determine whether the function represents y as a function of x. So yeah, if we solve for y, we would subtract the x cubed, and then to move the 5 to the other side, we would take the 5th root on both sides. Because we're doing an odd root, then you don't need that plus or minus, and it's going to represent a function, right? But if there was an even root, then it would not be a function, because then we would introduce a plus or minus. The domain, right? So we have a rational function. In general, the domain is all reals except any x that makes the denominator 0. And additionally, we can't take the square root of a negative, right? So normally it would be x plus 9 has to be greater than or equal to 0. But because it's in the denominator, it can't be equal to 0. So we would say x plus 9 has to be strictly greater than 0. So x is strictly greater than -9, right? So the domain here should be -9 up to infinity. Infinity always gets a parentheses, and in this case, because we don't want a 0 in the denominator, the -9 gets a parentheses as well. Okay. There's a lot of like background information. Like if you didn't practice, you wouldn't get that. Like you wouldn't just know that. That would come out of doing the homework. Use the graph to find the indicated value. So when x is 0, y is 0. Okay. One more. We're going to see how we did. It didn't take us that long to do that. We just did this one. So the initial cost to obtain the information for the job was $120. Each envelope costs 4 cents. Ooh, and they get paid 5 cents? Oh my goodness. So then the cost is going to be 4 cents, 0.04 for each envelope, plus the startup cost of $120. The revenue generated was 5 cents for each envelope. All right. I'm going to write out the part C. I'm going to say this comes from week 3 quiz. So we have week 3. This is 1.3 quiz. Let me see the time. I think we're okay on time. Okay. So we want to see when does the revenue equal the cost function, right? So then we have this 0.05x equals 0.04x plus 120, right? Okay, let me hop over to the tablet so you guys can see what I'm writing. Let's see. So now if we solve for x, instead of getting rid of my decimals this time, no, I can't do it. I'd rather just get rid of the decimals. I feel like I have a better chance of not making mistakes when I get rid of my decimals. So in this case, I'm going to multiply the left by 100 and the right by 100, and I'm going to distribute that 100 on the right. Okay. When I do this on the left, I get 5x. On the right, I get 4x plus the 120 with 2 additional zeros, so 12,000. Okay, subtract 4x on both sides. Okay, this adds to 0, and I think we get x equals 12,000 units. Okay, that looks good. So let's hop back over to the quiz. Let's submit this result. And so when x equals 12,000, that's similar to what we got before. So that's good. We're going to submit, and it should be okay. All right. All right, let's go do another one because I know we had other quizzes. Let me pull up one from a previous week. So we did that one. Let's go ahead and do. We might get a late penalty for this one because I know we're doing it late, but that's okay. I'm going to open up week 2, start the test, and then I need to be able to show it, which is it shown? That's interesting. I don't understand how this works. Okay, I'm not going to worry about it because it looks like it's showing. So I'm going to go full screen. Okay. All right. So let's take this quiz. Let me see. We get out at 6:30. I don't want to keep you more than about 15 minutes from now. So about 15 minutes more, and then, give or take a few minutes, and we can get out of here. I'll find the slope of the line if it exists, right? So slope is rise over run or change in y over change in x. So here, if we start at this point and get to the second point, we go what? Down 2 and right 2. So the slope is -1. The slope there should be -1, okay? And if we get it wrong, we'll come back and take it again and keep going until we get it. Write the equation of the horizontal line. So if it's a horizontal line, that means y is always that y value. So that's just going to be y equals 2. Okay. Use the given condition to find an equation in slope-intercept form of the line with this. Let's see. Use the given condition to find an equation in slope-intercept form of the line. If the line is vertical, write it in the form x equals h. The x-intercept is -2 and the y-intercept is 16. Let's write this one out. Okay. So this is week 2 quiz. So this comes from week 2, 1.2 quiz. Okay. This is question number 3. It doesn't tell us where in the book it comes from. I'm going to say find the equation of the line. Okay. Find the equation of the line. So it says the x-intercept is -2 and the y-intercept is 16. Okay. All right, let's hop over to the tablet so we can see what we're doing. So we're going to find the equation of the line. So the way I usually like to do this one, if the x-intercept is -2, I usually like to list out that ordered pair. I'm going to go to the next page. So the ordered pair there will be -2, 0. The y-intercept would be what? 0, not -16, 0, 16, right? So then I usually like to label my points when I get a set of ordered pairs. I'll go x1, y1, x2, y2, right? And we want to finish, I think, in the form, the slope-intercept form. So we want to finish in the form y equals mx plus b, okay? So let's find the slope. The slope formula is the rise over run, which is the change in y over change in x. So that's going to be y2 minus y1 over x2 minus x1. That's our slope. Okay. So that means our slope, let's see, we're going to have y2 minus y1 over x2 minus x1. Okay. y2 is 16, y1 is 0, x2 is 0, x1 is -2. Okay. So then on top, let me kind of move this around. On top, we're left with 16. On bottom, double negative is positive, so that's a 2. Ultimately, the slope is 8. Okay. Y was 7 afraid of 8. Did I do that right? No. Y was 6 afraid of 7 because 7, 8, 9. Okay. Yeah, that's how it goes. Okay. Anyway, so that's the slope. Oh, okay. So then now we can choose one point. I'm going to choose the second point because our x is 0, right? So if we let y be 16, the slope is 8, X is 0. Only thing we don't know is B, all right? Notice this term goes to 0, so then we get our result right off the bat. B equals 16. So we know the slope, we know the y-intercept, so then the equation of the line should be y equals 8x plus 16. Okay. So let's see. When x is negative 2, we get 0. When x is 0, we get 16. Okay. Let's go back and answer the question. Equation of the line is slope-intercept form. Okay, so equation, right? Y equals 8x plus 16. Y equals 8x plus 16. What's the time? Okay. We're going to go with this. Cancel. Cancel, cancel. Next question. Rewrite the given equation in slope-intercept form. What is the equation in slope-intercept form? So if we solve for y, we'll get y equals negative 6x plus 8. Okay. And then use the slope and y-intercept to graph the line. Okay. So the y-intercept is 8, so it's going to be a line. We go to 8, there's our first point. That's an 8 on the y-axis. And then it has a slope of negative 6. So we will go down to 2 and right by 1. That's the slope of negative 6. Save. Okay. And we got one more. I think that's it for that one. The equations of two lines are given. Determine if the lines are parallel, perpendicular, or neither. Okay, so as a quick recap, parallel, perpendicular, or neither is basically a discussion on slope. If two lines are parallel, that means they have the same slope. If two lines are perpendicular, then the first slope times the second slope equals -1. Or you may have heard it as the slopes are negative reciprocals of each other. Those two terms mean the same thing. The first slope times the second one equals -1, or two slopes being negative reciprocals of each other, they both mean that the lines are perpendicular, right? So what we need to do here is find the slope of each line. All right, let me take some notes. So this is still from that section. This is question number 5. This comes from 1.2 quiz, okay. So we have this negative 6x minus 2y equals -1, and we have 3x minus 9y equals 4, okay? Let's hop over to the tablet. Okay, so we're gonna say parallel, perpendicular, or neither. Okay, so if we're looking at, let's get a copy of the first one, the 6x minus 2y equals -1. Let's solve for y. I'm going to add 6x to both sides, so that'll give us a -2y. I'm going to get 6x minus 1, and I'm going to divide both sides by -2. Y equals -3x. It's like plus 1/2, right? Thank you. Scott Carson, I think that's here. Okay. Okay, so the slope there, so I'll say slope of line 1 is going to be what, a -3, right? So if we take the second equation, that's 3x minus 9y equals 4. We solve for y. So I'm going to subtract 3x on both sides. We'll get -9y and -3x plus 4. Divide both sides by -9. Y equals 1/3 x minus 4/9, right? So then the slope of line 2 is 1/3, right? Notice that, is it the case that slope 1 times slope 2, does that equal -1, right? So if we say -3 times 1/3, indeed it equals -1, it checks out. So then we would say that these two lines are perpendicular. So perpendicular. Okay, so the two lines are perpendicular. Let me leave a note. It says this means perpendicular. Okay. All right, so let's hop back over, submit it. We would say, now if we could guess, we get a 33% chance of being wrong if we just guessed, because it's like 1 out of 3. I'm gonna go perpendicular and submit. Oh, I think we just, yeah, we got it. We got everything correct. We just got point deduction because we submitted it late. All right, late submission, so we would get a 90 on this assignment, even though we got it all right. Okay, that's a good stopping point. That's more than enough for what we need. So for next time, we'll probably just get some more practice on factoring. If no one has questions, we'll just kind of practice like we did last week on factoring. But if you have questions over homework, we can actually, or about anything, we can actually take class time to answer those questions. Because these lectures are pre-recorded, you know, we can kind of take our time a little bit. But that's the gist of it, okay? So if there aren't any burning questions, I'm gonna release you all, our participants for the evening. And from one beautiful mind to another, enjoy the rest of your day. Take care, peace. Does seem like it just flashes the images of like somebody overcoming some trial, working hard day in and day out, doing what they gotta do. That's the images that I get in my head. Like heartache and pain, rain, sunshine, sleet, snow. That they're every day, day in and day out, doing what they gotta do. That's the vibe I get from this.